Hey everybody, welcome to the lesson for CTM 4.2. Can be found on these pages right here. Here's the vocab for this lesson. Make sure you understand all these things by the end of this lesson. And we've also got this, as always. Just make sure you're using those extra examples in your book. What I have here is just some additional examples to what's already in your book. But let's hope I don't fall asleep tonight. I'm doing this lecture kind of late. Let's just hope I don't fall asleep. I think I'll be okay doing this. But 4.2, place value or positional value numeration system. So let's talk about this system that we've been using all our lives, the Hindu-Arabic system. How does that system work? We don't really, I'm not sure if we've really appreciated our system and how nice it is, and how it wasn't just automatically there. We didn't just automatically think of this, or people weren't using this at the beginning of history, at the beginning of human history. This developed over time. So this is a place value system, this Hindu-Arabic system. It's a place value system. Why is it a place value system? Well, we have different values represented, different places representing different values. So we're used to seeing something like this. I'm just saying this would continue on this way forever, and so I'm just going to put some random numbers in here. I'll go with 8, 6, so I'm saying 8,652, and we also have decimals, so we have ours is a decimal number system as well. So this, let's say I had 3, 7. This could continue this way too. I could have numbers going this way. I think you learned this back in elementary school. So let's see if you remember your names of the places, the place value system. What place is this? Well, this is the thousands place. What place is this? Well, that's the hundreds place. And what place is this? That's the tens place. How about this one? That's the ones place. And then what about some of these other ones? This one, this is the tenths place. This is like 3/10 right there, and going to the right of the decimal. And I'll go back. Let's see. I'll go back to orange here. This is the hundredths place. And this would continue, the thousands place, the 10,000s place. This would continue this way, the 10,000s, the 100,000s, the millions, and so on. But basically what this comes down to for our system here, for our purposes, we need to know that this spot right there, that's like 1. That also equals 10 to the 0 power. So all these different places are just basically powers of 10. We have a base 10 system. This right here, I'll just go back and forth with red and blue, I guess here. I think that'll work well. That spot right there, that's 10 to the first power. And then this next spot right here, this is 10 to the second power. The 100th spot, 10 to the second power is 100. Got this next spot, 10 to the third power right here. The thousands place, 10 to the third power is 1,000. If you go backwards, we're not, for the purposes of this lesson, we're not terribly concerned about this little tidbit, but I think you should know this, that this would be, well, the pattern continues. 3, 2, 1, 0, it goes negative. So this is 10 to the negative 1 here. Or in other words, it's like 1 over 10, 1/10. And this, the 7, is in the hundreds place, so that's like 10 to the negative 2 power. Or in other words, 1 over 100, 1 over 10 squared. Remember, with negative exponents, you would make it a fraction, then flip the fraction, or you'd flip it on the bottom and make it a positive power. So this would continue, all these patterns. So place value system, because of what you see here, we have different places represented by different names like that. And base 10, so let's talk a little bit more about that. We said that we have a base 10 system. What does that mean more specifically? Well, base 10 means we have 10 digits. What are those digits? What are those 10 digits that we use? We use the digits 0 through 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are our 10 digits that we use. This word digits actually comes from, if you think of digits on your body, you have digits, your fingers are digits, your toes are digits, but usually we think of our fingers as digits. So one of the reasons why 10 became popular, because we had 10 fingers. 10 is also a very easy number to use. If you use the metric system, which we'll learn a lot more about later in this class, the metric system has powers of 10, and powers of 10, you just move the decimal. If you're multiplying or dividing, it's as easy as that. Other bases aren't quite as easy to manipulate, to maneuver with. I think you'll find some very interesting reading on page 175 if you're able to turn there. I would recommend doing that. You can learn more about the Hindu-Arabic system and how Hindus, they were in ancient India, they are in India, that's where it kind of developed. And so from there they traded a lot with the Arabs, and they developed this system of math, and with their system they're credited with coming up with 0, having that in their system. Also credited with quite a few other things, and with this whole system, basically they were able to trade a lot easier. They were able to make calculations a lot easier than their system that had been found. A lot more interesting reading. I'm no historian, but I've really enjoyed learning more about this as I've been able to read through some things here. So let's move on. I think I was all set. Just double check my notes here. Yeah, I was ready to go. So let's start working through some examples here. So let's start off with with this. Now we don't need to write that. I'm just going to say we're going to take this number, this Hindu-Arabic number, 3,822, and we're going to write that as a number in expanded form. So this is going to be in expanded form. So let's say this. We'll write in expanded form. I do want to get that phrase down in there. So let's see what that looks like. Expanded form. It may sound trickier than it actually is. So 3,822. I think I may have said we're going to write this in Babylonian terms. Yeah, we're getting there. We're not to that spot yet. We're just going to write this out in our expanded form. Here is 3 times, well, this is the thousands place, so it's 3 times 1,000. Or in other words, we saw that 3 times the thousands place was 10 to the 3rd power right here. So we would write that, or we could write that as 3 times 10 to the 3rd. And we have that plus, this would be 8 times 100, or in other words, 10 squared. This would be 2 times, that's 10 to the 1st, or just 10. And then this one's 2 times 10 to the 0 power, or just 1. So this is anything to the 0 power except for 0 is 1. 0 to the 0 power, that's just weird. So this is 3 times 1,000. This is 8 times 100. This is 2 times 10, so we'll just leave it just like that. And then this is 2 times 1, which we could write just as 2. So our book says we can change that to that, but the other ones we want to leave in this expanded out form. So this kind of longer form right here, this would be my final answer. Let's box that in. So this whole thing is expanded, the expanded form of this. But do you see how this is kind of like the multiplicative systems before? They would write 3 and then times another symbol, and 8 times another symbol. But see, I hope you see the advantage to this. So instead of having to write something like this, we can just write where the places are. That's representing 1,000, that's representing 100, and so on. And so it's much, much faster to use a form like this place value type system than it is to use a multiplicative system or an additive system or a ciphered system like we saw in the last lesson. But now let's talk about the Babylonian system a bit. So ancient Babylon, we've got ancient Babylon and kind of in this area. They had some really cool ancient structures there that they built, and Archaeologists still, I think, discovering things about ancient Babylon. Very, very intriguing culture. So let's write down some things that we know about their number system. It is basically the oldest known place value system. I'm going to say the oldest known place value-esque system. So it wasn't quite that is horrible. There we go. Place value-esque system. And it came about around 2500 BC. So 2500 years before Christ there. Really, really old system. I say esque because there's a couple of things it doesn't have that a place value system is supposed to have. There's actually no symbol for 0. Let's write that down. So there's a lack of a symbol for 0. Why that is, or why they never came up with something for 0, I'm not exactly sure. I feel like you've seen Back to the Future. It's a bit of an older movie, but a classic. I feel like if we could get a DeLorean time machine, go back to ancient Babylon and be like, hey guys, maybe you should think about putting a 0 in your number system. That might help a little bit. I don't know. I feel like that our math development and our development as cultures, I kind of just wonder what would happen if we could go back in time and be like, hey, here's some information, maybe you should do things this way instead. Like, where would we be now instead? Very, very intriguing, fascinating things to think about like that. So it led to a lot of ambiguity, a lot of unclarity. Like, okay, what number is that? There's supposed to be a 0 in there? Is there? What place is that exactly? So there was no 0. They couldn't tell if it was supposed to be a certain place or not. Yeah, it just seems like that's crazy to me, but that's how they dealt with things. And then we have a base 10 system, 10 digits. They had a base 60 system. A base 60 system. So essentially they had 60 digits. It's got kind of a funky name, but a base 60 system is called a sexagesimal system. So I think this is like a prefix meaning 60, something like that. And then the positional values. This is a term we definitely need to know for this lesson. Positional values. What are the positional values for us here? Well, if we go back to the Hindu-Arabic system, positional values, they were 10 to the third for the thousands place, 10 to the second for this place, 10 to the first, and then 1. And then we won't consider the decimal values for this lesson. So 1, 10 to the first, 10 to the second, 10 to the third. For the sake of the Babylonians, the Babylonian system, their place values were, well, let's kind of start backwards. Let me erase that. So they started off, they had kind of a ones place like that. And then they had, instead of a tens place, they had what essentially was a 60s place. And then their next place was a 60 squared place. And then their next one, the one before that, would be 60 cubed, and so on. This continued on and on this way. So instead of groups of 10, they had groups of 60. So groups of 60 here, and then a group of 60 squared would go here, and a group of 60 to the cubed. 60 cubed would go there. In the same way as for us 10, a group of 10 here, that goes here, a group of 10 squared goes here, a group of 10 cubed goes here. That's the difference here between the Babylonian system and ours. And then they had Babylonian, there we go. I'm just going to make a little table here for what they had. This isn't very long, so I want to practice writing this. And I'm thinking I may have you memorize these ones too, because there's only three basic symbols that you need to know for this. So the first one looks kind of like, to me it looks like kind of like a golf tee, filled in, kind of like that. So if you can look in your book and see a perfect drawing of that on on page 175. Table 4.5 has that. But a golf tee in Hindu Arabic, that's just 1. It's kind of like a tally system in addition to this positional value or place value system. So that represents 1. And then you've got what to me looks kind of like an arrowhead, like a Native American arrowhead. Something like that, but it's filled in. This represents 10. So this is 10. And then if you see something like this, it's basically to me, it's like a bigger golf tee, and then it points to the right instead, and it's like another arrowhead. This is a little thicker here relative to what this was here. You can see again a perfect picture of that is going to be on page 176 in your book. But if you see something like that, that's not a number. That means you're supposed to subtract things. So that's what we got here. And then if you see a gap, if you see a gap between these things written together, a gap, that implies that you have a different place value. So a different place value. So let's check out an example at this point. So example 2. We're going to write I won't write that this time. I'm just going to write out what we got. So saying these are my smaller golf tees, basically my little tally marks. So 1 and 1, and then put a gap here. So make sure it's a clearly an open space right there, and then we're going to have 2 of the arrowhead looking things, one like that, and another one just like that, and then 4 more ones, 4 more golf tees. Now I want to go golfing. It's been a long time since I've been golfing. I'm not good at it. I am, once in a while I'll get a good shot, just nail it down the fairway, but other times, just all over the place. It's a hard sport to be consistent with, that's for sure. Okay, so let's go back to what we had here, positional values. We're talking about positional values here. So I see, we're going to assume that there's no zeros in between here. Remember, there is no symbol for 0, so it could be, this could be the first position, and then the blank could actually mean there's a second one there that nobody ever mentioned because there's no way to write it, and then a third, but we're not going to get crazy like that. We're going to say that this is the first one. Let me use a different color for that. It shows up a little better. Okay, so this one is going to be that first position. Or in other words, it's just going to be the 1 right here. So that is just the 1. So we have this, and then the other position is going to be the group of 60. So this is going to be just groups of 1 right here, and then this is going to be groups of 60 right here. So this represents a group, or 2 groups of 60 basically. This will be 10, 20, 1, 2, 3, 4, 24 ones, and then this is 2 60s. So these are the positional values right here. Let's write that off to the side. These are the positional values right there. That's a bad looking S. There we go. That's a little better. So these are the positional values, the 1 and the 60 right here and right here. So after you've determined that, this becomes, I think, a pretty easy problem after that. After you realize, oh, that's all I got to do. I just have 2 times 60. I have 2 60s. And then over here I've got, that was the tally marks added up to 24. So I've got this 10, 20, 4 more. So I have 24 ones basically. I have 24 times 1. We work this out, we get 120 plus 24, and that equals 144. 94. There we go. So this Babylonian number is this for us in Hindu Arabic form. Let's check out another example similar to that, but we're going to use the subtraction symbol in this one. So another one like that. And then a gap. Oh, no. I'm just calling them golf tees because that's what they look like to me. And then a golf tee. So then a gap. And then we're going to have two more of the arrowhead looking things. So draw two of those. And then a bigger golf tee. This one's going to be the minus sign. This represents minus or subtracting. And then go with two smaller golf tees. And there is some thickness to these, so I'm kind of coloring them in. You can see again in your book what a perfect picture of them looks like. I feel like I'm doing a pretty good job here drawing. And as I say that, I draw probably my worst one yet. Isn't that how it always goes? When I'm watching sports on TV, they'll be like talking how this guy hasn't missed a free throw in so many tries, and there he goes. You jinxed him! But let's check this out now. So I've got three different place values now. This is still the ones. This is still the 60s. What is this one though? Again, let's go back to this. That's 160 and the 60 squared. So we just keep multiplying by 60 more. So let's write that out here. So this is going to be my ones. This is going to be my 60s right here. My groups of 60. And then this one's going to be my groups of 60 squared. Groups of 60 squared. So these are the positional values again. And later on, this blue step here, this is a step you could leave out later, but definitely write in your notes for now as we're getting used to doing these things. I doubt you've ever done something quite like this before this class, and the same holds for me too. I never learned how to do Babylonian numbers until teaching this class here. So we have 11 times 60 squared. That's this group right here. We've got, this is 11, 10 plus 1 here, and then that's groups of 60 squared. This we have 20 minus 2, which is 18. So we have 18 groups of 60. And then we have, this is a 10, so we have 10, in a sense, 10 groups of 1, 10 times 1. Now we're just going to multiply this out. This becomes 11 times 3600. 6 times 6 is 36, and you got two more zeros multiplied together. So I'm going to rewrite this all out again. This could be a step. I could have put 3600 right here to begin. This could be a step you could skip later on. But we got 10 times 1, just rewriting that all down. Now I'll simplify everything at once. This will be 39,600. This will be 18 times 60. Definitely a helpful thing to have at this point would be a calculator. And so we have plus 10 right here. Add this all together, and you get 40,690. 40,690. So for the Babylonians, this was the way they wrote what we traditionally think of as 40,690. And so notice we multiplied. So I'm going to write that down. If you like that, it's important. So here, to go from Babylonian to Hindu Arabic, we multiplied. We did another example here. We did the same thing. We went from Babylonian to Hindu Arabic. We're going to multiply. If you're going to go backwards, it's kind of like, well, what's the inverse of multiplication? What's going to undo multiplication? You're going to divide instead. So we're going to do an example now where we start with a Hindu Arabic number and go to the Babylonian number. So let's say we start with this 317,351, 317,351. So let's write that as a Babylonian number. So first of all, let's put down our positional values again. So the positional values are, let's work our way backwards. So this is 1, 60, 60 squared comes next. In this system, 60 cubed comes next after that. That would continue, that pattern's 60 to the 4th, and so on. Another way to write this now, you could say 1, well that's just 1. 60, well that's just 60. 60 squared, that's 3600. 60 cubed, put that into a calculator and you get 216,000. And again, I'll put a comma there. That would continue going this way too. We won't need, for this class, we probably won't need anything bigger than this one. So how do we do these kinds of problems? Well, basically, it's a division problem here. You want to take this number and divide it by the biggest number in this list that will actually go into that. So here, if I went 60 to the 4th, I'd get a number that wouldn't go into there. 60 to the 3rd does. So I'm going to start off like this. And let's write this down as a note. We won't write this down for the other problems like this, but I think it's important to write this down here. So take the number and divide. This is how we'll do all these kinds of problems. And we're going from the Hindu Arabic to this other base number, this other system numeral. So take the number and divide by the largest possible positional value. So the largest possible positional value. So we want to take this number and divide it by, well, this is the largest possible one. The next one would be 60 times bigger than that, much bigger than 317,351. So we take this, and now let's do what we got there. I'll go red. That's fine. So 317,351 divided by 216,000. Now I'm going to take out a calculator here. And so I'm going to put this into a calculator, 317,351, and divided by 216,000. That is, well, I get 1 point and then I get a bunch of crazy stuff, some repeating digits here eventually. So what's the whole number? How many whole times is this going to this? That's what I'm really concerned about. So it's 1 whole time. So 1 with a remainder of, how can I figure out that remainder? Well, I have 1 whole 216,000 that goes into there. So all I really need to do, in this case, take 316,000 and subtract, come on, 300, clear all, there we go, 317,351, and subtract 216,000, because there was only one of them that went in there. And I see what that equals. That's a remainder of 101,351. So this was my group of 60 cubes. So this, I'm going to put that off to the side. This was 60 cubes right here. How many 60 cubes went into my original number? This many. So you had 1 with a remainder of that. So let's now take my remainder, 101,351. I'm going to write that down here, 101,351. Now I'm going to divide it by the next positional value, by 3,600. How many whole times does this go into this? Let's check that out. So let's clear that. I shouldn't have cleared that. I didn't need to clear that, but that's okay. I'll rewrite that. Okay. Divide by 3,600. 600. There we go. So it goes into there 28 whole times. So I'm going to write that down here, 28. And my remainder, well, let's see how that all works out. What's my remainder going to be? Well, I'm going to take my number here. I do have parentheses, so you can use the parentheses on your calculator to help you do this. If you don't use parentheses, it's going to do the wrong order of operations though. So I want to take this and subtract. I'm going to take this here. Well, your calculator, hopefully, if it knows order of operations, it would actually do the multiplication that we're going to do here first. But just to be safe, I'm going to put parentheses here. So I had 3,600, and I had 28 groups of 3,600 that went into there. So as long as your input looks like this into your calculator, you should be good to go. If your calculator knows the order of operations like most scientific calculators do, it would multiply first like it should before subtracting from that. But this is saying it's 100,800 right here is that, so let's subtract that from that, and I get a remainder of 551. So that's what's left over. So this is my 60 squared value in a sense. This is my 60 cubed value. What comes next now? So I take this 551 and I divide it by the next positional value. The next positional value is 60. How many 60s go into 551? Well, I know that 9 times 60 would be 540, so I won't use my calculator on this one. So I'll have 9 times 60 is 540, and I would have 11 left over. So I would have that. You could use your calculator if that didn't come to you, but that I just noticed that would be the case, and so I've got a remainder of 11 now. And I don't need to divide 11 by 1. I know what that's going to be. It's just going to be 11. So my final thing there is going to be an 11 for my last positional value. I guess I don't really need that equal sign there either. I'll erase that. Okay, so these numbers right here are my most important numbers to finish this problem off. So I'm going to now write down the Babylonian number. So there's one of these 60 cubed spots. So I have just one little golf tee there for my first place value, first positional value. Then a space, and then now my 60 squareds, that's going to be 28. So I got to draw 3 of these. Minus, I'm going to make a bigger golf tee, minus, point to the right for my subtraction, like that. So minus 2 would be 28. So I've got, that is my next grouping. Alright, leave a gap and then do 9. So a gap and then 9, easiest way to write that would be this. And then the bigger golf tee. Sorry, 11. I'm encroaching on your territory here, 11. There we go. And so that minus 1, that'd be 9. And then finally 11. Leave a gap again. This is your last positional value. You got, there's 10. And then one more for 11. So this here, the 60, I meant to write one more thing here, so I should have written, I wanted to write, that was the one positional value here. So this is this one, the 60 is this one, the 60 squared is this one, and the 60 cubed goes with that first one there. Okay, so now let's talk about the Mayan system and what that looked like. Before I do that though, there was one other thing I wanted to mention about this. Do we still use this? Is there any like remnant of this kind of system in our culture that we use today? Well, think about degrees in a circle, 360 degrees in a circle. That's 6 times 60, so it's kind of based on this idea of a base 60 system. Think of latitude and longitude on a world map, on a map. We still do have this. Well, think about hours. Not hours, but think about minutes in an hour. We got 60 minutes in an hour, so that's a base 60 system right there. So you may not think of it, may not realize it, but we do. We still have a lot of remnants of this. The nice thing about 60 is that, well, what numbers go into 60? Well, 2, 3, 4, 5, 6, 7 doesn't, but what else we got? The list keeps going. I was going to say 8, but 8 doesn't go into there. But if we take 360, then even more goes into that. That's why I use 360 degrees in a circle, because there's so many different numbers that divide evenly into 360. But let's talk about the Mayan system a little bit here, and we'll do some problems together with that as well. So the Mayan system, the Mayans, they lived over here. This is, if you know any your Mexican history or Mexican geography, this is the Yucatan Peninsula right here. So they lived on the Yucatan Peninsula. So this is modern day Mexico. And their system was based on religious or on their religious and agricultural calendars. And then their positional values, instead of base 60 like the Babylonians, instead of base 10 like what we use today, theirs essentially was base 20 with a twist. So here's positional values for them. So they started off, they had a 1, grouping of 1s, and then their next one was a group of 20. But then instead of 20 cubed, this is where it gets a little strange, but the book talks about this being because, or at least historians think that it's because that they had 360 days in their year, and so they did, instead of 20 times 20, which would be 400, they wanted to make it 360 for this next place, so it would match up with their calendars. So that's kind of why we say that here. So 18 times 20 is 360, and then the next one after that, then it's just multiples of 20, additional multiples of 20 after that. So it's 20 squared, it's 20, 18 times 20 cubed, and so on. It would be 18 times 20 to the 4th, 20 to the 5th, etc. So this, or you could say, if you multiply these things out, this becomes 144,000. This becomes 7,200. 18 times 20, that's 360. 20 is just 20, 1 is just 1. So you can think of it like this or like this. And they had 20 digits in their system. Unlike the Babylonians, they did have a symbol for 0. So good job, Mayans. You got a symbol for 0. That's going to help a lot. So here's 0, and then 1 is just 1 dot. Basically, you go up to 4 with the 4 dots, and then 5 becomes a bar. Every bar is 5. Every dot is 1. And it goes all the way up to 19. Once you get there, then you have another place value that gets added to that. So there's 20 digits. Those are the 20 digits. And do I expect you to memorize these? No, but these really shouldn't be that hard to memorize, though. The idea, the concept that this 1 dot is 1 and then 1 bar is a 5, that should be pretty easy to remember, I hope. And then these are written like the traditional Chinese symbols or numerals as well. These are written vertically. So let's check out some examples with that. So here's some Mayan numerals. We're going to use this table to help us decipher or determine what this is. So we're going to start with 2 dots and then leave a decent gap there. That's going to represent our next position. If we draw it too close, then it's hard to tell if it's 2 or if it would be 7 if I drew a bar there. So I'm going to say that, and then I'm going to make a little gap here. Put these pretty close so I recognize that they're together. This is the 1 and 5 together would make a 6. And then finally, let's do 3 bars here. What's 3 bars? Well, that's 5, 5, and 5. That's 15 right here. So what is this as a Hindu Arabic number? So this, I'm just going to write it right up here. Let's just do these values. So this is my first place value, my second place value, and my third one right there. what value is this? Well, this is, I think I'm going to move this down a little bit. Sorry, this is why we use pencil hopefully on our notes here. Oh, I didn't want to move the whole thing. Let me see if I can move that up. There we go. I want a little bit of space here to write that down. Okay. So off to the side here. Nope. There we go. Yes. Okay. This is going to be my positional value right here. I want to move that even a little bit farther. Okay. Sorry about that. And I did it again. There we go. So here I'm going to put my positional value in a column over here. So this positional value, let's start down here with the bottom one. This is a positional value of 1. So that goes along with this. This one is a positional value of 20. And then the next one is where it's kind of strange, but 18 times 20 now is the next positional value. So this one is a group of 18 times 20. Okay, so let's work this out. So how many ones do I have? Well, I have 15 ones. So this would look like, or this part would equal 15 times 1. So 15 times, I don't really need the parentheses there, but I'm just kind of making a connection here to here. This is the same thing here, so 15 for that. This is 6 times 20. I have 6 groups of 20, in other words. So this becomes 6 times 20, that's 120. I'm going to try to keep these lined up as best I can. And then here I've got 2 times, this becomes, I could write it as 360 right away. I'll keep it as 18 times 20 for now. But this would be 2 times 360, which is 720. If you add all these together, you got 5, you got a 5, and you got an 8 here. So 855, this would be my final number. That's my final Babylonian, or not Babylonian, my final Hindu-Arabic number from a Mayan number over here. So just like before, let's make a connection here. So here we were multiplying, here we were multiplying when we're going from the other form of the number to our styled number, our Hindu-Arabic number. On this one, what do we do? When we're going reverse order, we are dividing. Let's put that in here. So here we would divide, and the same sort of thing works with the Mayan system. So here we went from Mayan to our system. We're going to multiply. We'll do one more like this. So let's see, and there's one of the ancient Mayan gods that I forget which one. That's in your book though, if you want to look at that briefly. That was their god of wind and rain, apparently. So our next one will be, let's talk about it now, it's on my mind. This guy was apparently their god of sun. Let's go back to example 6 and write down another one. So I'll be good here and leave some space here. So writing this vertically, we'll put our positional values here, but I'm going to have 4 different positional values, or 4 different places for this one. So let me draw that with a dot above there. Let me draw a 0 here. There's a 0. And then a little gap, and then one more dot, and then finally we'll go with 2 bars and 3 dots above that. So what's this going to look like? Well, this positional value, again, that's what I need to think of. This could be a column you leave out later when you're working on problems, on homework or classwork problems. But this is going to be the positional value of 1. This is still the 20. This is still 18 times 20. And what was that next one again? If you forgot, go back to this. 18 times 20 squared, then 20 cubed would continue like that from there. So this is 18 times 20 squared. So how many ones do I have? Well, this is 13, and I have 13 ones. That's all I really need to do there. So 13 times 1 This is going to equal, this one I'm going to put off to the side here a little bit more so I can add my final column or my final numbers together a little easier. So that's 13. How many groups of 20 do I have? I just have 1. So this is equal to 1 times 20, which is 20. Put that right there. How many groups of 360? 18 times 20. How many groups of 360 do I have? I've got none of those. So this would be 0. I could write 0 times 18 times 20. But that would, is 0 times anything, is 0. And then how many of these do I have? How many 18 times 20 squared do I have? I've got, this is 11, so I've got 11 of those. 11 times 18 times 20 squared. This would be, oops, 18 times 20 squared. This would be a good time to use a calculator there to work it out. I've already done that myself, so I got this, 79,200. Now if I put all these together, this should give me my answer. In Hindu Arabic, this would be a 3, and I've just got 7, 9, and a 2. So this number in Mayan is this number for us in Hindu Arabic, 79,233. So this was like this one. We were going from the new system to our system. We multiply to do that. So let's write that here. Just trying to connect all these problems together, link them all together. You see that it's basically done the same way every time. The different systems, you still treat them the same way in this lesson. Let's do one now where we're going to go in reverse. So that'll be our last one here. So we'll take a number like this, Hindu Arabic, and go to a Mayan system. How will that work out? If we're going in reverse, we should be thinking that we should be dividing here. And that's exactly what we will have. So this, let's write down our Hindu Arabic numbers. Start here. Let's go with 5,068. 5,068. The positional values, let's write those down again. Positional values. So let's see if you remember them. Let's start from the beginning. We have 1. Do you remember the next one? You say 20, you got it. What's that next one? It's kind of strange, kind of weird, but 18 times 20. And the next one, 18 times 20 squared. And the next one would be 18 times 20 cubed, and that pattern would continue. But for the purposes of here, this is all we're going to need. So we have to say this, or, and this is the same thing as 7,200. This is the same thing as 360. 20 is 20, 1 is 1. Okay, so we're taking this, and now we want to divide. So what do I want to divide? Go back to example 4 here. It's done the same sort of way as this was. So you had your positional values here. You're looking for the number, the largest possible positional value that goes into the number here. So positional value here, the largest one was that. The largest one for us here, that's going to go into 5,068. Well, 7,200 doesn't make the cut. It's too big, so we got to go to this one. So there's no groups of 7,200 that would go into here, but there are groups of 360 that would go into there. So let me just look back here. I'll use the same color, so I'll go with red. Okay, so I'm going to take 5,068 and see how many groups of 360 go into that. So this, if I work that out, I'll take my calculator back out here. 5,068 divided by 360 is 14.07 repeating. So how many whole groups go into there? There's 14 with a remainder of, so it's not an exact number here. Let's work that out. So let's take 5,068, subtract how many groups of 360 go into that. We said 14, so we have 14, put that in parentheses here, 14 times 360. Close that, so what's left over? You have 28 left over. So this is 14 with a remainder of 28. Alright, so this was how many groups of 18 times 20 I had that went into there. So that's my first positional value that I could use there. How many groups of, so take now the 28 and divide it by 20. How many groups of 20 go into 28? There's just one. What's left over? Well, you'd have a remainder of 8. You did 28 divided by 20. So let's do that here. This is my how many groups of 20 went into there? Just one. And then what are you left over with? That's my final place value here, would just be 8. So if we're going to write this as a Mayan number now, these are my place values. I'm going to have on top a 14, and I'm going to have a 1 next and an 8 next. So I just need to make that look correct. So we can say 5068 is the same thing as this. So you got 14, that's 2 bars, 4 dots. You got a 1, put a little space there. A 1 would just be a single dot, and then an 8 would be a bar and 3 dots above that. So this would be it. Written vertically, Mayans writing those vertically. That is our final answer. Hope you found that helpful. Please let me know in class if you have any questions or you want to go over any of these problems together. We can do that. Hopefully that went well for you. Hopefully you understood what was going on there, and hopefully the classwork will go well for you. I'll see you guys later.